Hi, my name is Shawn John, and I'll be presenting my molecule here, which is uric acid, discovered in 1776. I want to start this presentation by giving a background on uric acid. The compound is, of course, uric acid with the molecular formula C5H4N4O3. And to the right, you can see the shape of the compound. Below are physical characteristics of uric acid. The first is the melting point, which is greater than 300 degrees Celsius. Solubility is 60 milligrams per liter at 20 degrees Celsius, and molecular weight is approximately 168.11 grams per moles. Here below are some chemical characteristics of uric acid. One is that it forms ions and salts. As far as toxicity goes, levels above 6 milligrams per deciliter have had negative effects in humans. The graphic to my right clearly displays that anything over 5 can be dangerous to the human body. The shape of uric acid is a planar heterocyclic compound consisting of carbon, nitrogen, oxygen, and hydrogen. The graphic to your right clearly lets you see all the elements I just listed. When it comes to the symmetry of uric acid, no enantiomers could be found. However, I did find a structural isomer, 1-hydroxyxanthine. As you can see in the picture to the upper right, if you were to compare this picture with the picture of uric acid, you would see it's very similar. There are minor differences that make it not an enantiomer, but instead a structural isomer. So who discovered uric acid? That's a great question. This was Swedish scientist Carl Wilhelm Scheele in 1776. Scheele used kidney stones to isolate uric acid. And a fun fact about Scheele is that he independently discovered oxygen, chlorine, and manganese. The location and concentration of uric acid. In humans, uric acid is a natural component of urine. This uric acid can be found mostly in the kidneys. And for its concentration goes, 15 to 80 milligrams per liter is normal concentration for humans. So what makes uric acid so infamous? One unique thing about uric acid is that too much can hurt you, and having too little could also hurt you. And this, I will talk about this later on when you run into some of the side effects that happen that will come along with this. And as far as classes go, it belongs to class imidazopyrimidines. Another infamous thing about uric acid is where it's located. It is not just found in humans. And if you look at this diagram, it is found in primates, humans, dogs, birds, and even reptiles. In humans and primates, uric acid is excreted by urine, and uric acid is also a potent antioxidant for humans and primates. In birds, uric acid reduces water loss, which is beneficial to the birds in preventing dehydration. I will now explain why my molecule is a molecular villain and why it deserves to be known as Molecule of the Year. So there are two huge reasons why my molecule deserves to be known as a molecular villain. The first is hyperuricemia, which is high uric acid levels. This causes gout, which I will explain later, and causes of high uric acid levels include poor diet, fasting and/or quick weight loss, and thiazide diuretics. And the second I will mention is hyperuricemia, which is low uric acid levels, which produces harmful side effects, which I will again explain shortly. Below are three possible side effects of hyperuricemia. The first is gout, which is a form of inflammatory arthritis that attacks joints and causes redness and swelling. Eating foods such as seafood and drinking too much beer have been linked to gout. The second is tumor lysis syndrome. This occurs in patients following cancer treatment. When the cells begin to die, they release their contents into your bloodstream, causing high uric acid levels. This can lead to your kidney not functioning properly. The third is the Lesch-Nyhan syndrome. High uric acid levels have been accounted with this disease. Self-harm such as biting, head banging can be seen, as well as spastic movement. Lastly is the side effect of hyperuricemia. Low uric acid levels have been seen in patients with multiple sclerosis. MS causes the immune system to eat away at nerves, leaving the victim destabilized. To counter this, sufficient zinc levels will cause uric acid levels to rise. These side effects I mentioned make uric acid deserving of Molecule of the Year for being a molecular villain.